All right, so I'm gonna pull up the notes for today and Desmos. So make sure that you have Desmos pulled up. Today last week we talked about radical equations, so solving for x with a square root. Now we're going to look at that function on the graph, on the coordinate plane. The same thing, inverse variation problem is called a rational function, or sometimes you'll see reciprocal function. And we're going to look at that one on the graph as well. And we're going to find their domain and range. And we're going to find important points on their graph. So it's a day filled with domain and range. Yeah. Fun stuff. I'm getting I exited out of this earlier, so I'm going to fix it. And of course, you're being slow right now. Okay. All right. So as I'm waiting for my slow computer, I just wanted to point out the very first slide on this. So right here, this shows us the square root parent function. So remember, a parent function is like the most basic function of this square root family, and then we can build on it, add numbers, subtract numbers, multiply, divide, and we can change it, okay? So the square root of x is what a square root function, that's the most basic. So you see how there is an endpoint. So the graph isn't necessarily, it's continuous, but it has a stopping point right there, or we could say a starting point. So this one starts at 0, 0, and then it grows. So it is increasing. Does everybody see that it's increasing? But it's going to change our domain and range a little bit. So, we just went over in the warm-up reminding ourselves about a quadratic domain and range. Well, here, you're always going to have a number that you have a square bracket on the domain and the range because of that endpoint, okay? So I do think domain and range here is a lot. I think students kind of visually can see this one more than maybe others. So hopefully we'll do pretty good. So what we're going to do today, this is exactly what your practice is going to be like. We are going to review how to take a picture, because we're not going to graph by hand, but on your practice, I do want you to insert a picture. So I'm going to make sure that you can do that first. And then we're just going to use Desmos to find the endpoint, the domain, and the range. So what I'm going to do is just write, each of these functions in my notes and list the endpoint, the domain, and the range, because I don't think that we need to take 8 screenshots, as long as you know how to do that. So does everybody remember how to take a picture of the image on Desmos? I'm going to show you 2 different ways just to help, okay? So on number 1, we have f of x equals the square root of x plus 5. You can type f of x in there. You don't necessarily have to. Your square root is down here on the keypad, the square root of x. And then you want to be very careful as you graph these, because here the plus 5 is not inside of the square root. So you want to make sure you hit your right arrow to say plus 5. And then we'll drag the graph where we can see it well. So there's 2 ways to put a picture in your Google Slides, or for your practice, it'll be a Google Doc. So we're going to click Share Graph, Export Image, and it's going to show you the image there once it loads. All right, so, any kind of picture is fine. I'll be able to tell where that endpoint is. That's the main thing that we need to see. You can right-click and just copy the image. And then I could Control-V, paste right here, okay? I like better taking just a screenshot. So Control Shift and then the button with the box and 2 lines at the top. I can drag and cut my picture, what I want the picture to be, and then copy to clipboard. And so instead of this one, I can hit Control V and I can have that one. So I probably like that better. But anyway, you want to put the picture in there. You don't have to do it for the notes, but for the practice, it's like you're graphing it. So I want you to insert that into the Google Doc. Does everybody understand? Okay. All right, so from here on out, I am going to just use my notebook. So if you want those problems in front of you, make sure you have that pulled up, but I have them in front of me, so I'm just going to feed off that. So we already have the first one graphed in Desmos. So it was f of x equals the square root of x plus 5. And we want to find the endpoint, the domain, and the range. All right, so endpoint's pretty simple. So I'm going to go back. I'll have to go back and forth a lot. So going back to Desmos, I'm going to click. Sometimes this one doesn't like to click and hold, okay? But it's wherever that line is ending as we travel from the left. So that endpoint is at 0, 5, and then we increase. So 0, 5. So when we talk about the domain and the range then, okay, so let's think x values. So we're thinking x. So x values, we scan left or right. So what's the lowest x value that this graph uses? What is the x of your endpoint? 0. And then do we use positive x's after that, or are they negative? Positive, so that means it's growing, right? So our domain is going to be from 0, and 0 is included, so we put the square bracket, to positive infinity. Okay, let's talk range. Range goes up and down, okay? So look at this graph. What is the y value of our endpoint? 5. And then from 5, do we use y values lower than 5 or y values bigger than 5? What is this graph doing? It's going up. So do you think it's using numbers bigger than 5 or less than 5? Bigger. So that means we go from 5 to positive infinity. And that's all you're doing today. All right, number 2, f of x equals the square root x minus 1 minus 4. You want to make sure as you write it, the x minus 1 is underneath the square root, but the minus 4 is outside. All right, so I'm going to clear this out. You don't have to type square root or f of x if you don't want to. You can just start with the square root. So square root x minus 1 minus 4. And then once you get that in there, you may have to adjust your window here so you can see what it looks like. Because as we add and subtract numbers to this function, to the parent function, it moves all over the place. All right, so we have 3 things that we're going to find. First is the endpoint. So it's literally the end point, where the graph stops. And this is at 1, negative 4. Sometimes it is hard to get it to hold on to that point. 1, negative 4. Okay, now let's talk domain. Those are your x values. What is the x value of that point we just wrote down? 1. And then we're going to the right. So if we go to the right, that's positive infinity. So our domain goes from 1 to positive infinity. Okay, our range, we're going to use the y value of the endpoint, which was -4. And then our graph is increasing, it's going up, so it uses y values above -4. So that means that we're going from -4 to positive infinity. So the question probably is, okay, this seems pretty simple, but when is it not just like that? We are going to see some in a second where we will have a negative outside the square root, and it does change one of our characteristics there. I want you to practice the next two though. So we have f of x equals 3 times x plus 1. So that is correct. Okay, you're just going to put the 3 right beside the square root. It was being multiplied. And then actually just do that one. So I want everybody to try number 3. So even though this one might look a little funkier, okay, still the same stuff. So our endpoint is at -1, 0. And this graph is increasing. So we start at -1, 0, and we increase. So the domain is from -1 to positive infinity. And the range is from 0 to positive infinity. Any questions on that? So do we see the pattern with square root functions or radical functions? So that endpoint determines what your domain and range is. Do you notice that? So the endpoint, whatever it is, you use the x value goes in the domain and the y value goes in the range. The only other type that you may have is like number 4. So let's look at it. F of x equals negative square root x minus 2 plus 3. All right, negative square root x minus 2 plus 3. All right, so this one's not increasing anymore. Do y'all see how it's decreasing? So it's going to change things a little bit, but let's just take it one thing at a time. So the endpoint is at 2, 3. All right, let's talk domain, because it might, one of the domain or range may change because we're going down now. So the domain, we start, the x value here is at 2. But then look at the x-axis, what we're using. Are we using positive x values or negative x values? Positive, so x is still increasing. Do you see that? So think x value, look at the x-axis. From 2, we use 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're not using any of these negatives. So even though the graph is going down, the x's are still increasing. So that stays the same. So we're going to go from 2 to positive infinity. Okay, but now let's look at the y values. So we know we start at 3, but then this time 3 is the highest y value, and we're going down. So that means that we're going to negative infinity. Okay, so we have a 3 and we have a negative infinity, but let's remember how to write that. You write the lowest possible number first. So we're going to say parenthesis negative infinity to the maximum y value you have is 3. Okay, so I know I only have one example like that, but if you have a negative in front of your square root, the range changes. Other than that, everything's the same pattern. Pretty simple, hopefully. All right, so that is our radical or our square root function. Now, quickly, I want to look at, I'm going back to the notes. So we went through all of our examples there. Now we have a reciprocal function or rational function, okay? So you might hear both of those terms. A rational function, it looks a little different, doesn't it? So this is the parent function, 1 over x. What happens here is, when we have a fraction, any fraction, what number can you not have in the denominator? 0. So here when we have a function, if we have a 0 in the denominator, it makes it undefined. So what happens with our rational or reciprocal function is you have to look at the denominator, and whatever number is there, like if you make whatever number makes the bottom of that fraction 0, that can't be part of our domain and range because it's undefined. So this graph, as it approaches 0, it goes nuts, okay? So what's happening is we have these lines called asymptotes, okay? An asymptote is like an invisible line, but imagine you can have a vertical line and a horizontal line, and it's where the graph can't touch those, okay? So you can't touch an asymptote. And so as we have here, we have in the parent function, there is a vertical asymptote at 0, x equals 0. So that'd be vertical up and down through the origin. And then we have a horizontal, y equals 0. And if you think about it, if I would draw a line through where those are, the graph isn't touching them, okay? So it's a pretty interesting case scenario. Go to your notes. And I may, let's draw that just to remind ourselves. So here's the coordinate plane. And it might be hard to see here because we're right on top of the origin. But we have a vertical asymptote and we have a horizontal asymptote, both at 0. So that's why this function looks like this, because as it approaches both those lines, it goes crazy because it can't cross them. It can't touch them. Quick story. when I was in college, which it feels like it was just yesterday, but I'm approaching 10 years from my graduation in this June. But when I was in college, I was in the math department at NC State, and we had a T-shirt in one of the clubs that we had. This is going to sound so nerdy, but it was a math department T-shirt, and on the back it had a function like this, and it said NC State math or something like that, ... can't touch this. Get it? Because you can't touch the asymptotes. Yep, and I rocked that T-shirt. I was so proud of it. As a matter of fact, I made a T-shirt quilt not too long ago, and I have that T-shirt in the quilt. I should have brought it to school. But yeah, so you can't touch asymptotes, all right? So you could technically, never mind, I won't say that. No, I will. Technically, girls, you can walk up and be like, don't touch my asymptote. You like it, Nadia? Okay, I took it too far. I'm just trying to get something out of you guys. All right. Something else we need before we do examples. So it's how do you know the equations for those asymptotes? And that does dictate our domain and range. So we have a standard form of a reciprocal function. It looks like this. F of x equals a over x minus h plus k, where a, h, and k are all numbers, okay? Now, yeah, that looks complicated. But what you really need to know is for a vertical asymptote, I just misspelled that. Dadgummit. All right, so for a vertical asymptote, your equation is x equals h. For a horizontal asymptote, because you have both on these, your equation is y equals k. And if you can find those asymptotes, then your domain and range is going to be a piece of cake. All right, so let's look, though. Let me get one more highlighter to highlight this. Okay, so the vertical asymptote is just x equals h. H is going to be your number right here. But you have to be careful with this minus sign because the standard form has a minus sign, but if your problem had a plus sign, then h is going to be negative. Does that make sense? And then your horizontal asymptote is y equals k. It's just whatever number is added on to there, or it could be subtracted and you just have a negative k. That's good, or the k will be a negative number. So then, and let me give you this. This is going to be a super important piece of information right here. If now I'm going to give you something else for the domain and the range before we get started, and then you can just use this right here to help you. All right, so then the domain and the range. For domain, you're going to have negative infinity to your h value, union h value to positive infinity. And I know it's like, what? But remember that we can't cross those asymptotes, those numbers that make our function undefined. So h makes our function undefined. We can't, so it's going to be from negative infinity to positive infinity, except for h. Whatever h is, we can't cross that, okay? Your range is going to be negative infinity to k, union k to positive infinity. This just means that we include both. So it means that we are this and we're this, okay? We use both of those. So here it's saying that both of these are true. Now, this is a different type of notation there. It looks a little weird, but I want you, this is just like an intro into this type of notation because in Math 3, you're going to use this a lot. And I hope that next year you can be like, Miss Cook showed us that. Yeah. Okay? Now, this looks a little funky, doesn't it? But it'll be okay. All right, let's do some quick examples. Hang on to that. All right, I'm going to have to flip the page, but make sure that you refer back to that. All right, number 5. we have f of x equals 1 over x minus 2. So on this, I'm going to abbreviate vertical asymptote as VA, horizontal asymptote, actually I'm going to put it over here, horizontal asymptote, and then domain, and then range. I want to do it like that because those go together. So as we type this in, I'm just going to use slash for x, for the fraction, 1 slash x minus 2. Now, technically, to find everything that we need, you don't need the graph, you just need the function. But you can tell that we do have some asymptotes here. You can also sort of take a guess of it. So like if I'm looking at the vertical asymptote, it looks like it's the x equals 0 because it's going up and down through the origin. Don't you see? It looks like the graph gets close and close to the origin, but it never touches. So x equals 0 is going to be our vertical asymptote. Look horizontally right here. What number do you think might be the horizontal asymptote? Maybe negative 2. Okay, so do you see a pattern in the function where 0 and negative 2 might be? Okay, so let's talk about that. Remember that your vertical asymptote is x equals, and it was whatever number was h right here in the bottom. But if you just have an x, then that means that your vertical asymptote is at 0. Your horizontal asymptote is just the number that's added or subtracted out here. So that's negative 2. And that's y equals negative 2. So once you can get those, then your domain and range is pretty simple. We go from negative infinity to 0. We don't touch 0, so we use a regular parenthesis. And then we have 0. We don't touch 0. We might touch 0.00001, but we don't touch 0. And we go to positive infinity. All right, the range will be negative infinity to negative 2 and negative 2 to positive infinity. So it's always that pattern no matter what you have. You just have to find your numbers. So if you're like, man, I don't understand this, at least look at it as a pattern. All right, let's look at this one. So the vertical asymptote has to do with the denominator. What number can x be to make the bottom 0? Negative 3, right? Think about the standard form, though, that we wrote down. Remember, it was x minus h. So if the standard form is x minus h, then that means that we have x minus negative 3. So the vertical asymptote is at negative 3. The horizontal asymptote, there's nothing being added or subtracted out here, so it's 0. So then that makes our domain negative infinity to negative 3, negative 3 to positive infinity, and the range is negative infinity to 0, 0 to positive infinity. All right, y'all ready to try some? You don't have to graph them right now. I just want to see if you can find the vertical asymptote and the horizontal asymptote. So try 7 and 8. See if you can find those numbers. All right, so just to finish up here, for the vertical asymptote number 7, you're looking in the denominator, and you need to think, what number would x be to make it 0? It would be 0, right? Because that's what our vertical asymptote is. It's whatever makes the denominator 0. So then that makes our domain negative infinity to 0, 0 to positive infinity. The horizontal asymptote is just this number, whether it's positive, whether it's negative, it's y equals that number. So y equals 1. And then we have negative infinity to 1, 1 to positive infinity. Any questions on that one? Okay, on number 8, we got to think where x is. Plug numbers in. What number do I plug in to make that bottom 0? 2 minus 2 is 0. So that means that our vertical asymptote is at 2. So that's negative infinity to 2, 2 to positive infinity. And then the horizontal asymptote is whatever that number is added or subtracted. So it's negative 2. Do y'all want another one, or do you think you're okay on it? Thumbs up, thumbs down. All right, you have practice. Okay, so there is a practice. It's on a Google Doc, so make sure you make a copy and you submit it on Canvas. And it does ask for a picture of the graph just to show that you graphed it. All right, so you know how to take a screenshot. If you